Hello everyone, welcome to Unacademy. In this session, I will discuss Bitwise Operator. So the topic is Bitwise Operator. Sir, as the name signifies, we will work upon bit. Sir, what is a bit? Bit is a binary digit. Bit is a binary digit. That means one thing is sure that, sir, we will have to work upon the binary equivalent of the given number. We will not work upon the value as a whole, but first we have to find out the binary equivalent of a given number and then we will work upon it, because they are bitwise operator. That means we have to work on binary digits. We have to work upon 0, 1. Okay, sir. Sir, how many bitwise operators are there? So there are 6 bitwise operator. First one is Bitwise Xor Operator, and the symbol is single pipe. Then we have Bitwise AND Operator, and the symbol is a single ampersand. Sir, logical AND, the symbol for logical AND was 2 ampersand size. The symbol for logical OR are 2 pipe operators are there. Okay. Then we have Bitwise Xor Operator, Bitwise Xor Operator, and the symbol is caret symbol. Then we have Bitwise Left Shift Operator, Bitwise Left Shift Operator, and the symbol is, sir. Then we will discuss Bitwise Right Shift Operator, Bitwise Right Shift Operator, and the symbol is, and then we have Bitwise Complementation Operator, Bitwise Complementation, or you can think of it as Bitwise NOT, Bitwise NOT, and the symbol is a tilde. The symbol is called tilde symbol. This is a tilde symbol. Okay, so these are the operators we need to discuss. Sir, the big question in mind is, sir, all of them are binary operator. Sir, coming to Bitwise OR, binary. Only Bitwise Complementation Operator, that is Bitwise NOT operator, is unary. The remaining operators are binary operators. That means what they require, all of these require 2 operands to work upon, while this require only a single operand to work upon. Sir, let me start with a simple one. Sir, simple one. Void main int a is equal to 5, b is equal to 10, comma c, and c is equal to a or b. Printf percentage d, comma c. Sir, first of all, we are going to discuss Bitwise OR Operator. Bitwise OR Operator. Sir, how it works? The very first thing you need to understand is, sir, we are learning Bitwise Operator. That means we will not work upon this value as a whole. First, we need to convert both of the operand into their equivalent binary number. That means if I ask you, what is the binary equivalent of 5? Sir, we know the process. Sir, divide. Let us try to divide this 5 by 2. Sir, 2 when multiplied by 2 leaves a remainder 1. 2 multiplied by 2, that is 4, and sir, out of 5 remainder is 1. Okay. Then again, if I divide 2 by 2, sir, the quotient will be 1 and the remainder will be 0. Again, if I divide this 1 by 2, sir, the quotient will be 0 and this is the remainder. Sir, whenever we get quotient as 0, we stop the process. That means, sir, the binary equivalent of 5 is equal to 5 is 101. Okay. Sir, let's try to find out the binary equivalent of 10. 10. Sir, what if I divide 10 by 2? Let me again repeat the entire process. Sir, 5 times is 10. What is the remainder? The remainder will be 0. That means what is the quotient? Sir, the quotient is 5. Remainder is 0. Now, again we will divide the quotient we get, that is 5 by 2. Sir, 2 into 2 is 4. The remainder will be 1. So, quotient, if I divide 5 by 2, the quotient will be 2 and the remainder will be 1. Again, if I divide this 2 by 2, sir, 2 when divided by 2, 1 time is 2 and the remainder is 0. That means remainder is 0 and the quotient is 1. This is the quotient. Okay. Now again, if I divide this 1 by 2, 0 times is 0 and the remainder will be 1. The quotient will be 0. That means, sir, the quotient is 0 and the remainder is 1 and we will stop the process because the quotient turns out to be 0. So, what is the binary equivalent of 10? Sir, the binary equivalent of 10 is 1010. Try to understand. For 5, we get the binary equivalent as 101. For 10, we get the binary equivalent as 1010. Okay, sir. Sir, let us assume integer take 2 bytes in memory. What is the meaning of 2 bytes? The meaning of 2 bytes is nothing but 16 bits. So, let me first represent 5 in 16 bit. Sir, if we have 1, 0, 1, 3 bits, then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So, this is 5. This is our number A, first operand in binary. Sir, similarly, if I represent 1010 or 10 in 16 bit, sir, we will get something like this: 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Sir, we have both of our operands in corresponding binary. Sir, now how bitwise OR operator works? Sir, bitwise, the meaning is bitwise. That means, sir, this operator works upon this operator, or even all the bitwise operator works upon corresponding bits of both the operand. That means I am talking about binary operator. Sir, that means, sir, this is the first bit of A, this is the first bit of B. Sir, that means what we will perform? We will perform bitwise ORing of these bit, then bitwise ORing of these bit, bitwise ORing of these bit. That means, sir, bitwise operator actually what it takes, sir, it works upon bits, corresponding bits of both the operand. For example, sir, what if I say 1 ORing with 1? Sir, the first operand could be 0, second could be 1, 1 or 0, 0 or 0. Sir, the output of bitwise OR, is same. See how logical OR used to work? Sir, logical OR used to say if at least one of the operand is non-zero, then the result will be 1. Sir, what does bitwise OR says? If at least one bit is 1, the result will be 1. So, here, sir, both are 1. Sir, at least one bit is 1. Sir, here both the bits are 0. That means the output is 0. So, Sir, bitwise operator, what does it says? If at least one bit at least one bit, sir, it is working on 2 bits at a time. It is working on 2 bits at a time. So if at least one bit is 1, the output is 1. And the output is 0 otherwise. Otherwise, the output is 0. See, the output is also a bit. So, if I ask you 1 0, sir, at least 1 is 1. At least 1 bit is 1. 1 bit is 1. Okay. 1. Okay. 1. Okay. See, for these remaining bits, that means I am talking about these bits, sir, all are 0. So 0 or 0, that means 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Done, sir. That means what is the result of A or B? Sir, the result of A or B is this, but this is written in binary. This is written in binary. Sir, in our program, what we did? Sir, we are saying store this result inside C. Okay, okay. Sir, but we are trying to print %d comma C. How compiler will print? Sir, if you wanted to know the output of this, again, you have to convert this into decimal equivalent. So, sir, these are useless. Of course, that means if I ask you 1111 from binary to hexadecimal, sir, powers of 2 will be used. That means 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Sir, what is the value? 1 into 2 to the power 3, 1 into 2 to the power 2, 1 into 2 to the power 1, 1 into 2 to the power 0. 8, 4, 2 and 1. That means 15. Sir, actually the value of that number is 15. That means what is the value that goes inside C? Sir, the value that goes inside C is 15. That is why the output of this code is 15. So try to understand, sir, how bitwise operator works. First of all, we need to find the binary equivalent of both the operands. Then bit by bit, see, if you are working on a compiler in which integer is of 2 bytes, that means both the operand must have same bits. And bitwise operator works on corresponding bit. That means the same bit for this, that is for first, if I am saying this is first bit position, that means first bit of first operand as well as first bit of second operand. Sir, bitwise operator works on corresponding bits. It will not work like this. See, first bit of this will be odd with second bit of this. No, corresponding bits. Okay, sir. Let's try to solve few more questions, sir. Example 2. So again, void main int a is equal to 23, b is equal to 69, c, and c is equal to a bitwise or b printf %d comma c. Sir, first of all, we need to find the binary equivalent of a and b. So, sir, 23, let's try to find the binary equivalent. Sir, remainder. Sir, 2, 1, 2. Then 3, that is 11 times is 22. So remainder will be 1. Let me divide this 11 by 2. 2 into 5 is 10. The remainder will be 1. Again divide this 5 by 2. 2 into 2 is 4. The remainder will be 1. When I divide 2 by 2, sir, 1 time is 2. Remainder will be 0. Lastly, sir, when I divide 1 by 2, 0 times is 0. Remainder will be 1 and the quotient will be 0. We need to stop. That means, sir, this is the binary equivalent for 23. So, what is the binary equivalent of 23? 10111. 23 from decimal can be written as 10111 in binary. That is 5 bit. Okay. Sir, let me find the binary equivalent of 69. 2 34 times is 68. The remainder will be 1. The remainder will be 1. Again divide 34 by 2, sir, 17 times and the remainder will be 0. Divide 17 by 2, 2 into 8 is 16, the remainder will be 1. 2, sir, divide 8 by 2, sir, 4 times is 8, the remainder will be 0. 2, sir, even number, completely divisible, 2 times is 4, the remainder will be 0. When I divide 2 by 2, sir, 1 time and the remainder will be 0. Lastly, when I try to divide 1 by 2, sir, 0 times is 0 and the remainder will be 1. We need to stop because the quotient is 0. That means, what is the binary equivalent for 69? The binary equivalent for 69 is 1000101. 1000101. Sir, what is the next procedure? Let's write them in complete form. Sir, 10111. 5 bits, that means remaining 11 bits are 0, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then 101, always try to write from here, 101, because corresponding bits are important. So remaining bits are 0. Okay. Now, sir, let me perform bitwise OR. So, what does bitwise OR say? If at least one bit is 1, the output is 1. Otherwise, the output is 0. That means 1, 1, both are 1, 1, 1, 0, 1, again 1, both are 0, 0, 1, 0, 1, 0, 0, 0, 0, 1, 1. Sir, for remaining bits, all are 0. That's why 0, 0, 0, 0, 0, 0, 0, 0, 0. That means this is the binary equivalent for A or B. Sir, this is the value we are storing inside C, but this is in binary. Sir, let us try to convert this into decimal. So, sir, 101, see, do I need these bits? No, sir. Sir, 101, 0, 111, from a binary to decimal. Let's try to solve it. 101, 0, 1, 1, 1. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6. So 1 into 2 to the power 6, 0 into 2 to the power 5, 1 into 2 to the power 4, 0 into 2 to the power 3, 1 into 2 to the power 2, okay, plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. Sir, 64, 0 into something is 0, 2 to the power 4 is 16, 0 into something is 0, 2 to the power 2 is 4, 2 to the power 1 is 2 and 1. What is the answer? So 64 plus 16, 80 plus 4 plus 2 plus 1, I hope it is 87. Sir, the answer will be 87. That means, sir, actual value that goes inside C is 87. That means, what is the output of this code? The output of this code is 87. So, I hope you got an idea how bitwise OR operator used to work. Let me focus on next bitwise operator. So, sir, next bitwise operator is bitwise AND. Bitwise AND operator, and the symbol is AND. Sir, just like bitwise OR, this is also a bitwise operator as well as binary bitwise operator. That means it will take 2 operands. Again, just like bitwise OR, first we need to find the binary equivalent of both the operands, and then this operator works on corresponding bits of both the operands. Okay, let's see with an example. Sir, void main int a is equal to 5, b is equal to 9, c. And I am saying c is equal to a and b. Printf percentage D, comma C. Sir, sir, firstly, let's try to find out the binary equivalent for 5 and 9. So for 5, let me divide it by 2. Sir, if it is odd, remainder will be 1. 2 into 2 is 4, remainder will be 1. Okay. When I divide 2 by 2, sir, it goes one time, the quotient will be 1 and the remainder will be 0. Now if I try to divide 1 by 2, 0 times is 0, the remainder will be 1. Sir, we need to stop because we get the quotient as 0. So what is the binary equivalent of 5? 1, 0, 1. Okay. Sir, let's try to find the binary equivalent of 9. So here remainders. Sir, when I divide 9 by 2, 2 into 4 is 8, the remainder will be 1. That means what is the quotient? 4 and the remainder will be 1. Again, let me divide this 4 by 2. So 2 times is 4. That means the remainder will be 0. Sir, if I divide 2 by 2, it goes one time and the remainder will be 0. Again, if I divide 1 by 2, the remainder will be 1 and the quotient will be 0. Sir, we need to stop because quotient is 0. That means the binary equivalent for 9 is 1001. Sir. That means if I try to write A, sir, it is in 3 bits. So 101. See, don't try to do something like this 1001 and try to perform some operation. No. Corresponding bits, that means, sir, 1, always start from here. 1, 0, 0, 1. Sir, no bits are here. Okay. 0, 0, 0, 3, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Okay, sir. Sir, here the remaining bits, see, the remaining bits are 0. Okay, sir. Sir, now what we need to perform? We need to perform the bitwise ending. The bitwise ending, sir, this is B, that is 9. Sir, what does bitwise end say? It will take 2 bits. That means if I say, what is the result of 0 and 1? 1 and 0, 0 and 0, 1 and 1. It says the result will be 1 only when both the bits are 1. The result will be 1 only when both the bits are 1. It's just like AND. It's just like AND. Sir, if I'll say one number is 0 and multiply it with any number, sir, the result will be 0. Only when both the numbers are non-zero, that means 1, the result will be 1. Okay. So in only this case, the result will be 1. Otherwise, the result will be 0. That means the output is 1 only when both the bits are 1. When both bits are 1, the output or resultant bit, is 1. Otherwise, the resultant bit is 0. So 1 and 1, sir, 1. Both the bits are 1. See, 0, 0, 0, and these all are again 0. That means 0, 0, 0. All bits are 0. So this is what we get. Sir, this is the value that gets stored in C. Again, for evaluating the answer, we need to convert it into equivalent decimal. So, sir, all the 15 bits are 0. Sir, we only need this thing. Sir, 1 written in binary, what is its decimal equivalent? Okay, no issue. Sir, this is only 1. That means 2 to the power 0. 2 to the power 0. That means what is the answer? 1 into 2 to the power 0, that is 1 into 1. So our answer will be 1. That means what is the value that gets stored inside C? Sir, 1. That's why the output will be 1. Sir, the output of bitwise AND is 1 only if both the bits are 1. Otherwise, the output will be 0. Sir, let us solve a bigger question so that we will get some confidence. Okay. Void main end A is equal to 47, B is equal to 73, C is equal to A bitwise AND with B, and let us try to print the result of C. See, I strongly recommend that please pause the video and try to find the result by yourself. Sir, first try to find the binary equivalent for 47. 47 to remainder. Sir, 23 times the remainder will be 1. 2. 23 when divided by 2, 11 times is 22, the remainder will be 1. When 11 is divided by 2, sir, 5 times is 10, the remainder will be 1. Sir, again, when I divide 5 by 2, quotient will be 2 and the remainder will be 1. When I divide 2 by 2, sir, 1 time and the remainder will be 0. When I divide 1 by 2, sir, it goes 0 times and the remainder is still 1. So, this is the binary equivalent. Why we stop? Because the quotient turns out to be 0. So, the binary equivalent is 101, 111. Okay, done, sir. Let's try to find out the binary equivalent for second operand, that is 73. 2 and the remainder, sir, 36 times is 72 and the remainder will be 1. When I divide 36 by 2, it goes 18 times and the remainder will be 0. When I again divide 18 by 2, sir, the quotient will be 9, and the remainder will be 0. Again, let me divide 9 by 2. Sir, the quotient will be 4 and the remainder will be 1. Let me divide 4 by 2, it goes 2 times and the remainder will be 0. Sir, divide 2 by 2, quotient will be 1, remainder will be 0. Lastly, if I try to divide this 1 by 2, quotient will be 0 and the remainder will be as it is, that is 1. So, the binary equivalent for 73 is this. Sir, why did we stop? Because we get the quotient as 0. So, try to understand. Sir, the binary equivalent for A is 101, 101, 101, 111. That is in 6-bit. The binary equivalent for 73 is 100, 100, 100, 1001. Okay, sir. Sir, is it necessary to write all the bits? No, just they both must have the same number of bits, and alignment should be from right side. That means, sir, 0. If there is no bit, put a 0. Okay, let's try to find out. Sir, bitwise end. Why too unnecessary? Why too unnecessary? Waste the time. Sir. Let me perform. See, this is A and this is B. Okay, sir. Both bits are 1, then the result is 1. Both bits are 1, then the result will be 1. Sir, both bits are 1. No, that means result will be 0. 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 So, this is the output of A bitwise ending with B. That means, sir, this is the value that is being stored in C. But to evaluate it, sir, again we need conversion. So again, if I ask you 0, 0, 0, 1, 0, 0, 1 from binary to decimal, sir, do we need these bits? No, because all of them are 0. So, let me perform this. 1, 0, 0, 1 from binary to decimal. Sir, 1, 0, 0, 1. Powers of 2 will be used. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. That means, sir, face value multiplied by place value. 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 What is the answer? Sir, 8. See, 0 multiplied by anything is 0. 0 multiplied anything with 0. 1 into 1 is 1. That means 9 is the value that goes inside C. That means what is the result of C? Printing C. Sir, the result is 9. So that's how logical AND operator and logical OR operator used to work upon. Sir, bitwise operator, more specifically all binary bitwise operator, works on corresponding bits of both the operands. First, First, we need to find out the binary equivalent of both the operands, then perform the operation on corresponding bits to get the final result. So I hope things must be clear to everyone who is watching this video. Sir, let's move ahead and try to understand the third operator, that is called as Bitwise Xor Operator. Bitwise Xor Operator, caret symbol is there. Sir, now we know that it is also a binary operator. First, we need to find the binary equivalent for both the operand, and then on corresponding bits, we will perform Bitwise Xor. But what is the output of Bitwise Xor? Sir, that means I am asking these four. Sir, what are the output? That means, sir, both bits could be 0, both bits could be 1. First bit could be 0, second could be 1, first bit could be 1, second could be 0. Sir, always remember, sir, the output of XOR operator is 1 when both bits are different. That means in these cases, when both bits are different, that means if first is 1, second is 0, or first is 0, second is 1, then the answer is 1. Okay. And if both bits are same, either both are 1 or both are 0, if both bits are same, the result will be 0. That's it. That's how Bitwise Xor operator used to work. If both the bits are same, the output would be 0. If both the bits are different, the output would be 1. So let me take a simple example and let's try to solve it. Sir, hash include stdio.h void main. Let us suppose we have int a is equal to 5, b is equal to 10, or b is equal to 12. Let me make b is equal to 17, comma c. And sir, I am saying c is equal to a XOR with b, bitwise XOR, and print the value of result. That is printf %d, comma c. Sir, first let's try to find out the binary equivalent for 5. Sir, we have already find it so many times, but okay, just for practice purpose. Sir, when I divide 5 by 2, it goes 2 times and the remainder will be 1. When I again divide 2 by 2, it goes 1 time and the remainder will be 0. If I divide 1 by 2, it goes 0 times and the remainder will be 1. Sir, we need to stop. The binary equivalent is 101. Okay. Let's try to find out the binary equivalent of 17. 2. Sir, 8 times is 16, the remainder will be 1. When I divide 8 by 2, it goes 4 times and the remainder will be 0. Again, if I divide 4 by 2, it goes 2 times and the remainder will be 0. If I divide 2 by 2, it goes 1 time and the remainder will be 0. When I divide 1 by 2, sir, it goes 0 times and the remainder will be same as 1. So this is the binary equivalent. So let's try to understand. Sir, the binary equivalent of 5 is 101 and the binary equivalent for 17 is 10001. I am writing it like this way. Sir, do I need to write all 16 bits? No, sir. 2 bits are missing from here, so 0 and 0. Sir, let us perform the bitwise XOR. So, sir, both the bits are same. Both bits are same. So the result will be 0. Sir, both bits are same. The result will be 0. Both bits are same. Result will be 0. But, sir, both bits are different. The result will be 1. Both bits are different. The result will be 1. So this is the result of A XORing with B. But Sir, this is written in binary. So to evaluate the answer, to evaluate what is to be printed by this printf, first we need to convert this into equivalent decimal. So let me convert 10100. Sir, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3 and 2 to the power 4. So 1 into 2 to the power 4 plus 0 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 0 into 2 to the power 0. See, 0 into something is 0, 0 into something is 0, 0 into something is 0. 1 into 2 to the power 4 is 16 plus 0, that is okay. Sir, 1 into 2 to the power 2 is 4. That means what is the answer? 20 is the value that gets stored inside C. So what is the output of this? Sir, the output of this code is nothing but 20. I hope you get to know how XOR operator is working. Sir, let's take last example. Sir, void main int a is equal to 106, b is equal to let us suppose 163, c is equal to a XOR b, and let's try to print the value of result, that is c. Sir, since we are using bitwise operator, first we need to find out the binary equivalent for both the operands. So let me find out the binary equivalent for 106. Sir, 2. When I divide 106 by 2, since it is an even number, remainder will be 0 for sure. And let me divide, sir, 5 and 3. Sir, let me divide 53 by 2. Sir, it goes 26 times. 2 into 26 is 52, so leaves a remainder of 1. Sir, if I divide 26 by 2, it goes 13 times and the remainder will be 0. Again, if I divide 13 by 2, it goes 6 times and the remainder will be 1. Sir, let me divide 6 by 2, it goes 3 times and the remainder will be 0. If I divide 3 by 2, it goes 1 time and the remainder will be 1. Sir, again, if I divide this 1 by 2, it goes 0 times and the remainder will be 1. Sir, we need to stop because we get quotient as 0. So what is the binary equivalent? Sir, 1101 1101010. Okay. Sir, let me try to find out the binary equivalent for 163. Store the remainder. Let me divide. Sir, 81 times is 162. The remainder will be 1. If I divide 81 by 2, it goes 40 times and the remainder will be 1. If I divide 40 by 2, we know 20, remainder will be 0. Let me divide 20 by 2, 10 and remainder will be 0. Sir, if I divide 10 by 2, 5 times, remainder will be 0. If I divide 5 by 2, it is 2 times, the remainder will be 1. If I divide 2 by 2, it goes 1 time and the remainder will be 0. If I divide 1 by 2, quotient will be 0 and the remainder will be 1. So this is the binary equivalent for 163. Let me write them. Sir, 106, that is 111101011010, 7 bits. But sir, here 1010100011, that means 8 bits. Sir, these are 7 bit and now 8 bits, that is 10101000110011. Sir, 8 bits, 7 bits, append a 0. Okay. Sir, let me perform the XOR. Sir, for XOR, if both the bits are 1 or both the bits are 0, that means if both bits are same, the result will be 0. Otherwise, the result will be 1. So, see, both bits are same or different? Different. That means 1. Both bits are same? 0. Both bits are same? 0. Both bits are different? 1. Both bits are same? 0. Both bits are same? 0. Both are different? 1. Both are different? 1. So, this is the value that gets stored inside C. Sir, let us try to convert this binary into its equivalent decimal. So, sir, 11001001. Sir, for binary, powers of 2 will be used. Okay. 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. That means 1 into 2 to the power 7, 1 into 2 to the power 6, 0 into 2 to the power 5, 0 into 2 to the power 4, 1 into 2 to the power 3, 0 into 2 to the power 2, 0 into 2 to the power 1, 1 into 2 to the power 0. Sir, what is the result? 128 plus 64 plus 0 plus 0 plus 8 plus 0 plus 0 plus 1. So what is the result? 192 plus 8 plus 1. I hope the answer is 201. So this is the value that gets stored inside C. So what is the output of this? Sir, the answer is 201. And I am assuming that all the calculation done by me is correct. No silly mistake. So that's all. That's all for this session. We have discussed bitwise operator. How many are they? There are 6 bitwise operator. Out of them, 5 are binary, 1 is unary. And in this session, we have covered bitwise OR, bitwise AND, and bitwise XOR. So that's all for this session. Bye-bye. Take care.